Okay. Well, good morning to the 3 people in the chat. We're still waiting for a few folks to come on in, but you know, it's still early. You know, class hasn't officially started yet, so thanks for hanging out. We'll just wait for more folks to pop in. Hey, look at that, 7 people. Okay, cool. We're still gonna wait for a few more people to come up. Oh, 9 people, that's good. What time does class start again? I think 10:05. So we'll get started in just a minute. It'd be nice if we had at least 10 people. sure this will help. This is Kima. Okay. Are we going to do online tests if the school year continues with online instruction? Not exactly. At least, I mean, I can speak for my plans for this class. What's going to happen in your other classes, as far as I understand, that is at the discretion of that teacher. So, like, I can't really tell you what's going to happen in your English class or your science class or any of your sort of options or anything like that. I mean, that might change. We might all have to do something that's been prescribed by the, by the Winnipeg School Division, for example. Maybe they'll come up with a plan. There's a lot of uncertainty here, so I don't know exactly what is going to come of it. But so let's just take a few hypotheticals here. So if school reopens after the break, or like the week after March break, then yeah, we would just go back to business as usual, and we would have just real tests. If we don't go back, like if we do continue to do online instruction, and the Winnipeg School Division or Grant Park High School or any kind of the institutions that we are kind of under, if they don't prescribe anything, then I'll do some online assignments. So I'm not really sure how I feel about online tests, but online assignments I think are a little bit easier to manage. And if the school division or Grant Park does prescribe something, well then we'll just go with whatever that is. But at this point I haven't heard anything, so as far as I know, we are going back to school after the week, or sorry, I guess the week after March break. So is that going to change? I don't know. I don't really have enough knowledge to be able to comment on that in any kind of informed way. If I did say something, it would just be a guess, and I'm not an expert, so I'm really not the person to ask, right? I'm not the best person to ask. So I'm not going to say anything because I do kind of have some authority here, right? I'm your teacher, so I really want to make sure that none of my words are misunderstood. Like, I don't want to say something and then have all my students, say, oh yeah, school's canceled for the rest of the year because my teacher said so. Like, no, I don't want to. I want to stay away from that. So I'm not going to say anything about whether or not I think school is going to be closed or anything like that. So yeah, if you're wondering, you could I would just keep your eye on the Winnipeg School Division website and see what they say, because honestly, like, I will know pretty much the same time that you will know. It's not like they'll just tell me and then keep it a secret, right? They would make it announced to everyone pretty much at the same time, as far as I understand. So anyway, we have 11 people here, which is about half the class. It seems as though there's over the past couple of days, I've noticed that maybe about somewhere between 1/3 and 1/2 of the students are watching live, which is awesome. That makes me super happy. I honestly, I was expecting a quarter. I was expecting 25%. So to have a third, like 30%, all the way up to 50%, like we have now, that's awesome. I'm very happy about those numbers. In any case, what I'm also noticing is that some people are watching it after the fact, so that's also good too. And it's nice too that it's like on YouTube now. So a couple students have reached out to me. They asked a question, and I had one student who asked me a question yesterday afternoon, and I didn't have time to answer that question, so I didn't reply to their email. And then they emailed me later on that evening and said, you know what, I actually watched your video a couple more times, and I think I figured it out. So so that's great. I think that this is kind of cool that this is all on YouTube, and you know, we're like 22 minutes already into this video. So and a cool thing about if you're watching it after the fact, you can just fast forward through all of this, right? So when you're watching a YouTube video, your arrow keys can kind of skip over a few seconds, so you can just spam the forward key and kind of ignore all of my banter. Okay, I had a couple ideas of what I wanted to do today. Wrote them down here. So I want to take a look at what's called I've been referring to as the stretch factor when we're in vertex form, because I think that's been causing a little bit of confusion for some students. And then I want to look at some word problems, because I think it's really important to be able to sort of interpret sort of a real life scenario and be able to use quadratic equations and some of the stuff that we've been learning about quadratics in such a way that allows us to answer real world problems, because that's a really cool part of math, is that it can solve real world problems. I watched a YouTube video today about just how some of the mathematicians are being asked about the spread of the coronavirus, and how there's all sorts of different mathematical models that we can use to sort of predict what can happen next. So yeah, I mean, mathematics has a lot of really cool applications. So it's really important that we learn how to, you know, interpret real life scenarios, and with those scenarios be able to predict what happens with some level of accuracy in the future. Okay, so let's talk a little bit about the stretch factor. So let's go, okay, alright, so stretch factor. So we're going to talk about the stretch factor in vertex form. Okay, that stretch factor in vertex form. Okay, so recall, when a quadratic function is in vertex form, it has the form a times x minus p squared plus q. And I should say that this is f of x equals. The vertex is at the point p comma q, and the stretch factor, which is what I'm calling it, is a. So that tells us how much we are going to stretch our parabola. It's also going to tell us if we're going to stretch it up or stretch it down. So if it's negative, it would stretch it down. Okay. Okay, so some students want to know how to give an example of going from vertex form to factored form. Yeah, absolutely, we can do that. But let's talk about this first. So let's talk about what this a means. I think that a lot of us are okay with vertex, like we know where the vertex is going to go. We know how to interpret that. But this stretch factor, let's just make sure that we know that one, because I'm not sure if we spent too much time talking about what the stretch really does. So why don't we head over to what do you call it? What am I trying to say? Desmos. There we go. Okay, let's go to Desmos and see what happens with Desmos. Okay, so I'm going to just start off with the equation. I'm going to just plug my keyboard right into my iPad. Okay, so let's start off with the equation. Let's try y equals x squared. Okay, so that's just the classic typical parabola, and what we're going to notice here is that if I go over 1, I go up 1, right, because 1 times 1 is 1. If I go over 2, well, that's going to give me 2 squared, which is 4, right? So I've got 2, 4 right there. If I can just, there it is. So I've got 2, 4. If I go over 3, so going over 1, 1, there's 1, 2, and then 3, then I'm going to get 9, because 3 squared is 9, okay? Now, if, again, the same thing is happening on the other side because it's mirrored, because when I square something, it automatically becomes positive. So I'm going to get the same thing on the left as I do on the right. So if I want to stretch this, I'm going to get something that looks like this. So let's say I have, can I just do this? Yeah, I'm going to add a slider A. Oh, perfect. Okay, so right now A is equal to 1. And let's see what happens when I move this slider left and right. So it kind of looks like I'm squishing it and pulling it. But really what's happening is that it's kind of like a vertical stretch. So I'm stretching it up and down like this. It kind of looks like you're opening it up, but that's not exactly the best way to think about it. What's really happening is that we're stretching it vertically. So the higher my x gets, well, let's think about what we're doing here in terms of the actual function. So I guess I can't really zoom in here. Here, oh, I know how to zoom in. I'm going to regret this, I think, but let's just roll with it. Okay, so let's take a look at what's happening with this AX business right over here. So as I change this value, what's happening is I'm multiplying x squared by a. So remember, we have to be aware of our order of operations here. So remember that we do exponents first and then we do multiplication. So what I'm trying to say is this a business, what we're doing when we're multiplying is that we do that sort of after the fact. So if I multiply a by x squared, well, that's going to make my value either higher if a is positive or lower if a is negative, right? So when a is negative, we get this business over here, and I knew I'd regret this. Oops. Okay, so yeah, I really regret this now. Okay, whatever. Just bear with me while I fix my screen here. Can I do this? Sorry, folks. I thought that I could just easily zoom in, but now I can't. Preview scaling, scale to window. No. Sorry, guys. Transform. Fit to screen. Okay, and is that going to work? Yeah, that looks good. Okay. That looks, we could probably do better, but whatever. Okay, so where was it? Oh yeah, so when a is When a is negative, then we're going to look something like this, because now we're multiplying by a negative number. So if you want to know what the stretch factor does exactly with your points, well, when a is equal to 1, we're going to multiply this whole thing by 1. So I go over 1 and I go up 1, because 1 squared is 1, and then 1 times 1 is 1. Let's make this a 2 and see what happens. So I'm going to turn that into a 2. Now I go over 1. Come on. I go over 1, and well, 1 squared is 1, but then 1 times 2 is 2. If I go over 2 now, well, 2 squared is 4, and 4 times 2 is 8. Now, if I go over 3, I'm going to be at 18. So, I go over 3, I square 3, which is 9, and 9 times 2 is 18. So that's what the stretch factor is doing, is we're just multiplying our numbers. So what we're going to be doing when we're graphing these is we're going to just have to be aware that we need to memorize our first few squares, right? So when I've been graphing these, you may have been hearing me say things like, oh, I'm going to go over 1, up 1, over 2, up 4, over 3, up 9, right? And that's because 1 squared is 1, 2 squared is 4, 3 squared is 9. You know, if we wanted to, we could go up 4 to 16, so over 4, up 16. But now that we have this stretch factor, we have to be aware that we're going to multiply that square by our stretch factor. And that's the whole point of the stretch factor, is that whatever our squares, we're going to multiply that by our stretch factor. Okay? So let's do a quick example. So I'll pull up an example from our, actually, you know what, I'll just make an example up. So yeah, let's do this. So e.g. Graph, let's do 3 times x minus 1, and I should say y equals 3 times x minus 1 minus, let's do 10. Okay, so my vertex is going to be at the point 1, negative 10, and my stretch factor is going to be 3. Okay, so let's see what that looks like. So I'm going to make my my Cartesian plane. It looks something like this, and I think that will be in the negatives quite a bit, so I'll kind of make it like that. And let's see here. So my vertex is at 1, negative 10, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's my vertex. My stretch factor is 3, so whatever I do, I'm going to square however far I go left and right, and then I'm going to multiply that by 3. So if I go over 1, I'm going to go up 1 times 3. So I'm going to go up 1, 2, 3. Oops, I had my eraser on. Okay, let's try that again. 1, 2, 3. Here we go. And then I'm going to do the same thing on the left. Now if I go over 2, normally I would go up 4 because 2 squared is 4, so I'm going to go over 2 and then up 1, 2, 3, 4. But I'm going to go up 4 times 3, which is 12. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is right there, and I'll do the same thing on the left. And those are the only points I'm going to graph, because if I graph the other one, I would have to go over 3 and then go up 9 and then do 9 times 3, which is 27, and I don't want to have to count 27 up. It wouldn't look very nice. It would be like way like up here, I think. So we're going to start making the parabola. So remember that it's nice and flat at the bottom. So make sure that you're making your parabolas nice and flat at the bottom. They're not pointy. So we're going to go up like this, and then we're just going to sort of connect these ones. Now keep in mind, it's not a straight line between these. There is some curvature. Okay? So it's going to look something like that. And there's our parabola. Isn't that nice and beautiful? Okay, so that's that. What next? What did I want to show you next? Oh yeah, word problems. Okay, let's do some word problems. Um, After that, what I'd like us to look at is I'd like us to look at assignments going forward. So I did sign us up for something called CrowdMark. So we're going to take a look at CrowdMark in a second. But let's do some word problems first, and then I'll talk to you a little bit about CrowdMark. Are there any questions before we move forward about the stretch factor or anything like that? We don't have positive 1 and negative 10. I think we do. Oh shoot, I forgot something really important here. This is supposed to be a squared. Oh, and yeah, you're right. Okay, so let's do this. The easiest way to fix this is to turn this into a plus. Haha. And then I've got minus 1, minus 10. There we go. Yeah, good point. Yeah, my bad. So I got the vertex right. I forgot to put the exponent on there, but then I moved it over to the left instead of to the right. So sometimes the easiest thing to do when you're a math teacher and you make a mistake is to change the question, because then you don't have to go back and change all of the work that you did. Yeah, so good point. I made a little mistake there. Yeah, that should, but I changed the question in such a way that now it is correct. So, so if you want, you can just change the question if you're writing this as we go along too. Okay, can we learn switching between them like oh yeah, sure. Yeah, let's go back and forth between factored form and vertex form. So, so we've got those three types, right? So we've got standard form, we have factored form, and we have vertex form. So we have these three types. Okay, so I think that the easiest type to get to is standard form. So no matter what we would do, if we want to go from factored form to standard form, all we have to do is expand. So we would expand the brackets. Okay, so that one's fairly straightforward. If we want to go from vertex form to standard form, again, what we would do is we would expand, except what we're doing is we're going to expand the exponents, right? Because it's going to be in, why don't I actually write an example? So this would be ax squared plus bx plus c. This one would be x minus, I don't know, what do we call it? S and t, x minus s and x minus t. Doesn't really matter which letters we use. And then vertex form is going to look something like a times x minus p squared plus q. Okay. Okay. So, so yeah, what we would do to go from vertex form to standard form is we would just expand the exponents. We might have to collect some like terms, but really all we're doing with standard form is that we're just getting rid of any kind of brackets and exponents and just cleaning it all up so we have a nice looking polynomial. So I'm not going to go over that because it's fairly straightforward. Let's talk about, and I guess we've also gone from, choose a different color here. We also have gone from standard form to factored form, right? So there's I'll just call it factoring strategies, right? Because there's a lot of different ways to factor a trinomial or a quadratic expression, however you want to call it. So we would just factor it using one of the many strategies that we have. And to go from standard to vertex form, well, to go there, what we do is we complete the square. We complete the square. Okay. All right. So yeah. So that's basically what we do. But I think that what some people are asking is, can you just like go back and forth between these two? Like, can you just go like from here to here? How do you do that? Well, let's talk about that for a second. So I mean, one way to do it, I mean, if you think of this kind of like a road map, or kind of like directions, like how do you go from point A to point B? Like if we're trying to go from vertex form to factored form, well, we could just follow one of these arrows, right? So let's say we're starting at vertex form and we want to end up at factored form. What we could do is we could expand the brackets, or sorry, expand the exponents, right? And then now we could factor it, right? So then we could go there. So basically what we would do is we could take it from vertex form and put it into standard form, and then bring it back into factored form. So that's one way to do it. And similarly, you could kind of go backwards too. So if you want to go from factored form to vertex form, you could take this, right, and then here's you'd put it into standard form, and then follow the arrows until you get to vertex form. So that's one way to do it. So I hope that makes sense. Like, as long as there's an arrow between every two pairs, then you can go from any one to the other, right? So I can certainly just follow these arrows around. There is a faster way though that takes less work to go from vertex form to factored form, and that's what I'll show you how to do now. Okay, so how to go from vertex form. So how to go from vertex form to factored form. Okay, and just one thing to note. And we still have to talk a little bit about the discriminant here, because I think that's where we left off yesterday, right? Yesterday we kind of ended up talking about roots and stuff, but I don't think we talked too much about the discriminant. So we'll have to talk a little bit about the discriminant in just a second. But the idea is that if we want to go from vertex form to factored form, we do have to be aware that not all quadratics can be factored. Okay? And this has everything to do with the discriminant. So we'll talk about the discriminant in a second, but let's just roll with what we have so far, and then we'll talk about the discriminant and how it plays a role in this whole thing. So okay, not all quadratics can be factored. Yeah. Okay. So we're gonna go from we're gonna start with vertex form, and our goal is to go into factored form. So we're going to start off with something that looks like this. So a times x minus p squared plus q. Okay, and for now, what we're going to do is we're going to set this equal to 0. Okay, so we're going to go from one to the other. So we're setting this equal to 0. So we've got everything on one side, and on the other side is equal to 0. Then what we're going to do next is, well, we're going to bring this q over to the other side. We're basically just going to be doing the same thing that we did with the proof of the what am I trying to say? Quadratic formula. We're still sort of just completing the square, and once we complete the square, then we're going to solve for x. So I'll have that a times x minus p is equal to negative q, and then that's squared, and I will divide that by a, so I've got x minus p squared is equal to negative q over a, and now I'm going to take the square root of both sides, plus minus, which gives me x minus p is equal to plus or minus the square root of negative q over a. Oops, that's supposed to be a. All right, and then x is equal to p plus or minus the square root of negative q over a. Okay, so what that means, so this means we can factor the equation, or I guess I should say the quadratic, as x plus p plus or minus the square root of negative q over a times x, or I should say minus, this should be minus, x minus p plus or minus, or sorry, sorry about this, plus and then minus the square root of negative q over a. Okay, so this is what it would look like. So that would be in factored form. Now the tricky thing is, and we're going to get to this when we talk about the discriminant, is like what happens if we're taking the square root of a negative? Like we've got a negative in here, but remember it's a variable, so if q is negative, then it would actually be positive, or if a was negative, we get another positive. So as long as q is negative here, or a is negative, we're okay, and hopefully that makes sense. So let's take another look at Desmos here. This time I'm not going to try to zoom in. So let's take a look at a case where I've got a positive, and it doesn't really matter what's going on with p squared, and let's call this 3, and then plus 5. Okay, so in this case you'll notice that both a and q are positive. So going back here, if a and q are both positive, then we'd be taking the square root of a negative number, which means that you can't do that. You can't take the square root of a negative number. So so we can't factor that, because if we could factor it, then it would be possible for this equation to be equal to 0. Or in other words, it would have an x-intercept. This equation has no x-intercept at all, right? It's way above. But if one of these is negative, so if we made either q negative or a negative, so let's make a negative. Well, now we've got x-intercepts, right? So as long as one of them is negative, not both of them. If they're both negative, then we have a problem, because now we would have sort of the same issue. So we can't factor that, right? This is not factorable because it has no x-intercepts. When we factor a quadratic, essentially what we're doing is we're finding its x-intercepts. We're finding the roots of that quadratic. So we do have to be careful about calculating roots and factors and things like that. So hopefully that makes a little bit of sense. But in general, if you want to go back and forth between vertex form and factored form, a really straightforward way to do it is just to go from vertex form to standard form, and then from standard form to factored form. That's probably the easiest way to do it. But if you want to go directly there, what you would do is you would just sort of solve for x, and whatever whatever x is equal to, you would add and subtract that, because you're going to get a plus minus because you'll have to take the square root at some point. So you'll get two solutions, and as long as you subtract both of those solutions, then that will be factored form. Should probably do an example for that, eh? So let's do an example. Okay, so let's say that we want to convert. Let's say 2 times x plus 4 squared minus 6. And let's call this y equals. So y equals 2 times x plus 4 squared minus 6 into factored form. Okay, so we're going to turn that into factored form. Okay, so let's go ahead and do that. So what I'm going to do is I'm just going to set this all equal to 0. So we'll say that 0 is equal to, well, 2 times x plus 4 squared minus 6. Okay, and then I'm going to solve for x. So I'm going to get 2 times x plus 4 squared equals 6. And then I'll divide both sides by 2. So I've got x plus 4 squared equals 3. And I'm going to take the square root of both sides. We'll get x plus 4 equals plus or minus the square root of 3. And then finally, I've got x is equal to negative 4 plus or minus the square root of 3. So those are my two solutions. So if I want to write this in factored form now, I can write x plus 4 minus the square root of 3 and x plus 4 plus the square root of 3 equals y. So I've gone ahead and I've factored that equation. Okay. So that's how you would go from one to the other. Okay, let's talk a little bit about the discriminant, and I'm starting to realize now that we're running out of time, so I think that we're going to have to leave word problems for tomorrow, because I would like to talk a little bit about CrowdMark and how to log in and that kind of thing. So let's talk about the discriminant. Okay, and let's use a capital D, the discriminant, because this is a title. Okay, so in the quadratic formula, we have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's our beautiful quadratic formula. This little portion right here is really important. So I'm going to change this color. Okay. So the portion of the formula underneath the square root plays a crucial role in the use of the formula. Okay. The reason why, so why? Well, it's actually fairly straightforward, because we cannot take the square root of a negative number. At least not in the set of real numbers, right? So not in R. You can take a square root of a negative number in the complex numbers, but if we're dealing with just real numbers, which is what we're dealing with, you cannot take square roots of negatives. So what does this mean? Well, well, hold on. Before we talk about what this means, let's just talk about what the discriminant is, and then we'll talk about what it means, because it'll just be a lot easier if we have a word to describe the object that we're talking about. So let's just develop a wee bit of vocabulary. I just need to teach you one word, which is the discriminant, and you may have already figured out what the discriminant is by now. So the discriminant is b squared minus 4ac. Okay? Now that discriminant is going to tell you a lot about the quadratic function. So thought I heard something. Okay, so the discriminant, that's b squared minus 4ac. If the discriminant is negative, we cannot take any square roots of it. Okay? So, since the quadratic formula tells us how to find the roots of a quadratic function, i.e. the x-intercepts, if the discriminant is negative, we can't, or we have no x-intercepts. Okay? So that's the whole point of the discriminant, is just to say, okay, well, not all of our quadratic functions have x-intercepts. Not all of them have roots, right? So the discriminant will tell us right away whether or not we have any. So as a matter of fact, there are 3 possibilities. So there are 3 possibilities. Okay, so the first possibility is 2 roots. Okay, so that's where we have something that looks like this. Okay. Okay, so we'd have 1 root there and 1 root there, and that is when the discriminant is greater than 0. Okay? Because we would be doing something like this. We do plus and minus the square root of a positive number. So this plus VE, let me just make that nice. This plus VE, this stands for a positive. So if I've got a positive number, then I'm going to plus and minus a positive number. So that's going to give me 2 values, right? One where I add the value and one where I subtract the value. Okay, the second possibility is 1 root. Okay, and that's going to look something like this. Okay, where the quadratic function just grazes the x-axis. Okay, and this is when the discriminant is equal to 0. Because we would have plus or minus the square root of 0, and the square root of 0 is just 0. So we'd be adding and subtracting 0. It doesn't matter if you add 0 or you subtract 0, you're not changing anything. So that's why you only get 1 root. Okay? And the third option, the third possibility, is the one that we just talked about. That is no roots. Okay, and that looks something like this. Okay, and what colors was I using? Yellow and green. Okay, so okay, no roots, and that happens when the discriminant is less than 0, because we would be taking the square root of a you're taking the square root of a negative number. Okay, so you can't take the square root of a negative number, at least not in the set of real numbers. You wouldn't get a real number, and we're only really dealing with real numbers. So we have no roots. You can't take the square root of a negative number, so you have no roots. So the quadratic formula is not going to help us find any roots because we don't have any roots. So at some point we would be taking the square root of a negative, and we would just have to halt. It's kind of like dividing by 0. Can't do it. So we kind of just say, you know what, there's no roots here. Okay. I just want to talk a little bit about what we would write if there's no roots. We actually want to write no real roots, because, so I'll just put that asterisk there, because we can have complex roots. Okay, so for example, so e.g., the square root of -1, that is the special number called I, and I is the unique number whose square is equal to -1. This is a complex number, so I is a complex number. We're not going to really deal with complex numbers. I just want to tell you what I'm talking about if I say there's no real roots. Just know that you can take the square root of a negative number. It's just not a real number. You have to introduce a whole new number system called the complex numbers, and there's a whole beautiful area of mathematics that deals with complex numbers. It's a really fascinating sort of group of numbers, and there's a lot of beautiful symmetries in there, and it ends up acting a lot like the real numbers, but in kind of like in a two-dimensional way. Anyway, so we're not going to talk about that, but so that's what the discriminant is all about. Is that it tells us how many roots we have in our polynomial. So I think we're going to leave it there. I'm going to put some homework on the website, and I'm going to talk a little bit about CrowdMark now. So I've signed everyone up already. So you should be able to log in now. Let me just quickly pull up CrowdMark here. So CrowdMark. Okay, so this is CrowdMark. Hopefully you can see that okay. So what you can do is, as far as I understand, you can sign in, and so I think what you would do is you would look up Grant Park High School. There we are. Are you a student? So click in with your email and password. And since you don't have a password yet, I think you would have to do unlock and then punch in your Winnipeg School Division email address, and it'll give you some instructions on how to sign in. And now I just have to tell you, like, I haven't used this system before, so I'm still learning how it works. So we're gonna just have to learn how this works together. So let me just verify, just to make sure that I don't have some kind of like unlock code for you. I don't think I do, but let me just double check. So let's see here. Yeah, I don't think course settings, yeah, I don't think I can like invite you or anything like that. So, but in any case, all of you have a an account already. I've already signed you up using your Winnipeg School Division email address. So if you I'm assuming that if you click or type in a like your email into the unlock instructions, then they'll just send you a way to activate your account. So I'm hoping that we can try to be flexible with this, because I wish that I'd had the opportunity to use this software already. Yeah, if you have difficulties logging in, definitely let me know as soon as possible, and I will do my best to make sure that it works. But if it doesn't work, then we'll have to figure something else out. But as far as I understand, it should work pretty well. I'm still, like I say, I'm still learning how to use it properly. So yeah, I think I put just one little assignment on there already, but it's not really like an assignment that I'm going to use for marks. It's just, let's see exactly what I put on there. So just like 2 questions. The first question was, were there any difficulties logging in? Oh, it looks like someone actually already, oh cool, look at that. I actually have a couple of answers already. This is fantastic. And then I put a note about, are you interested in Discord? Okay. Alright. Okay, cool. So we are going to give that a shot. So it looks like some people have already been able to sign in. So that tells me that we can actually log in. So I'm assuming that if you check your email now, there's probably already some kind of invite code, because I don't think I told anyone about CrowdMark already. So I'm guessing that when I signed everyone's email up, that they got some kind of notification in their inbox. So yeah, hopefully that makes sense. And here we go. Okay, it looks like a few people are saying stuff in the chat. Okay, so email isn't locked. It gave me an error. I just went forget password and sent a reset thing. Tried 2 and did that. So does it forget password? Okay. You can't access your Winnipeg School Division emails? I think it has to be your Winnipeg School Division email address. I think that anything that I sign us up for, we have to use the Winnipeg School Division emails. Where does it say you don't have access to your school email? Okay, but like where does it like, are you trying to access your student email, or is it from can you access your email? Like your can you check your school email? Is what I'm trying to ask. You should be able to log into your school email. I'll put the email. Where's the email? There it is. So does your email address not work when you go to the link that I just gave you? Okay. So it looks like it's starting to work now. So that's good. Okay, do you want to just tell people what you did? I mean, I wish I could give you proper instructions, but because I don't have a student email address, I can't like tell you from my own experience how this works. So if you got it to work, can you just write a little note on how you got it to work in the chat? I'm assuming that you would just check your Winnipeg School Division email, and there's probably. What do you mean you just kept trying? What did you try? Like what did you do? Like did you click forgot password? Did you log in to the email account? Okay, so you click forgot password. So did you not get an email from Crowdmark? I would have assumed that you'd have got an email. Yeah, once you're into Crowdmark, once you're there, um, yeah, once you're there, then there's only one assignment. So I just asked a couple of questions. It's not going to be worth any marks, but I'd like us to sort of get the hang of how this system works. So please do it. Okay, so the problem was actually getting into your school email. So yeah, did the link that I give you work? The studentmail.wsd1.org. Did that link work? Because that should be the link that you can use to access your student email. You could also use Outlook on your phone. That's the app that I use for my for my emails. As far as I know, Outlook works really well for our school division emails. Okay, so it looks like people are starting to get it. So unless I have a misunderstanding, you should be able to just log into your school email, and there should be some kind of invite code from Crowdmark. If not, you can go to Crowdmark, try to log in, and then click Forgot Password, and just make sure that you use your Winnipeg School Division email address. So that should do the trick. So. Okay, so is the only way to do the assignment by uploading pictures, or can you just type your response? As far as I understand, you can type your response for like later on when we start doing math. You like if the answer was like 6, then you could probably just type 6. But if it's going to be a question where I want to see your your work, then I would like you to photograph your work. So that's how we'll kind of proceed. Is that if it's a question that you can type, then type it. Otherwise, I'd like you to take a photograph of your work. So, anyways, I'm gonna sign out now. And if you have any questions about how Crowdmark works, or about any of the math that we covered today, send me a message either on Instagram or what have you. So yeah, let me know. And I will sign in sometime tomorrow. Looks like there's a couple more questions here in the chat. So there is no place to type it, though, for this assignment. Okay. Then I guess you're going to have to take a picture. One thing you could do, you could open up like the Notes app in your phone and type it there, and then take a screenshot and then upload the screenshot if you prefer to do it that way. Whatever you want. Or if you're on a computer, you could use Microsoft Word and then take a screenshot of that. So we're just going to have to problem solve this one as we learn this new piece of software. So how do I type it in? All this is, yeah, so just take a picture. So yeah, I think that screenshots is probably the best course of action. So okay, well I'm gonna go, and I will sign in tomorrow, and I hope that you are able to show up and have a good day. Don't forget to brush your teeth, have a shower, keep up with your personal hygiene. Super easy to let that stuff go when you're all by yourself in your own home. Yeah, I'm gonna go brush my teeth right now, because maybe this is an overshare, but I haven't brushed my teeth yet today, so I'm gonna go brush them now, maybe have a shower, and then have lunch. Okay, bye bye.